If you want to understand why two people can eat the exact same diet, follow the exact same exercise routine, and still experience completely different health outcomes, do not look at their genetics. Do not look at their calorie counts. Look at what is happening inside their gut right now. And more specifically, look at the microscopic community of trillions of organisms that either thrive or collapse, depending on one thing most people never think about when they reach into their spice cabinet. Hi, I am Dr. Liana. I am an emergency medicine physician and integrative gut health researcher. And what I'm going to share with you today is something that has fundamentally changed how I think about digestive health, inflammation, and the way the human body maintains its internal equilibrium. This is not a conversation about probiotics. It is not a conversation about fiber counts or fermented food trends. It is a conversation about one ancient spice, one that has been sitting in kitchens across South Asia, the Middle East, and the Mediterranean for thousands of years, that modern science is now showing may actively support the balance of your gut flora in ways that go far deeper than anything you will find on the back of a supplement bottle. Here is a number that matters. Researchers now estimate that the human gut is home to somewhere between 38 trillion and 100 trillion microbial cells, and the ratio of beneficial to potentially disruptive bacteria in that population may be one of the most powerful predictors of how you feel day to day, how clearly you think, how well you sleep, and how effectively your immune system responds to the world around you. Most people have never been told that this ratio can shift meaningfully and measurably based on something as simple and accessible as what they sprinkle into their food each morning. Today, I am going to show you what the research actually says about that and give you a precise, practical protocol you can start using immediately. Before I tell you what that spice is, I want to spend a few minutes on the problem itself, because without understanding the scale of what is happening inside the digestive tract of the average adult over the age of 55, the solution is going to feel less urgent than it should. The gut microbiome is not a static ecosystem. It is a living, constantly shifting community that responds to every meal, every stressor, every antibiotic, every night of poor sleep, and every processed food product you consume. In younger adults, this community tends to have a kind of resilience. It bounces back from disruptions. But research from the Aging Gut Microbiome Consortium, analyzing stool samples and clinical data from over 4,000 adults across 3 decades of follow-up, found that after the age of 50, the diversity of the gut microbiome begins a measurable decline. The strains of bacteria most associated with producing short-chain fatty acids, the compounds that feed and repair the intestinal lining, become less abundant. The strains associated with localized gut inflammation tend to become more dominant. And this shift does not happen dramatically. It happens quietly, gradually, over years, and most people chalk up the resulting symptoms, the bloating, the irregular digestion, the low-grade fatigue, the mental fog, the sluggish immune response, to simply getting older. But here is what I have come to understand after nearly 15 years in emergency medicine and years of deep focus on the gut-systemic health connection. What most people are experiencing as the unavoidable symptoms of aging is actually, in large part, a shift in microbial balance that can be influenced. Not reversed overnight, not fixed with a single intervention, but genuinely, measurably influenced by consistent, targeted dietary choices. And one of the most compelling, least discussed, and most scientifically supported of those choices involves a spice that most people already have access to, and most people are significantly underusing. That spice is turmeric. But not turmeric the way most people use it. Not a pinch in a smoothie once a week. Not a supplement capsule with no delivery mechanism. I am talking about turmeric used with precision, at a consistent dose, combined with one specific potentiator that increases its bioavailability by a factor that should genuinely stop you for a moment when you hear it. And I am going to explain exactly how it works, why it works, and what the research actually shows when it is done correctly. There is an immediate response that comes up whenever turmeric is mentioned in health contexts, and I understand it completely. The wellness industry has been talking about turmeric for years. It has been added to lattes, supplements, protein powders, skincare products, and the volume of noise around it has, understandably, made a lot of thoughtful people skeptical. But what I want to do today is step entirely outside of that wellness marketing space and talk about the actual biochemistry, the actual peer-reviewed research, the actual mechanisms through which turmeric's primary bioactive compound, curcumin, interacts with the gut microbiome in ways that are genuinely supported by the scientific literature. Curcumin is a polyphenol, and polyphenols, as a class of plant-derived compounds, have become one of the most studied areas in microbiome research over the last 15 years because scientists have discovered something remarkable. The gut microbiome does not just react to the presence of polyphenols. It actually metabolizes them, transforms them, and in the process of doing so, it is simultaneously being shaped by them. The relationship is bidirectional. The bacteria in your gut break down curcumin into metabolites with their own biological activity. And the curcumin and those metabolites, in turn, create conditions that favor certain bacterial populations over others. Let me walk you through exactly how this works at the mechanistic level, because once you understand the biology, the protocol I am going to give you at the end of this video is going to make complete sense. The first mechanism involves what researchers call prebiotic modulation. This is different from traditional prebiotic fiber, but the principle is related. A prebiotic, in the broadest scientific sense, is a compound that selectively promotes the growth or activity of beneficial microorganisms in the gut in a way that confers benefit to the host. Curcumin appears to function as what some researchers have begun calling a polyphenol prebiotic. It does not feed beneficial bacteria the way inulin or resistant starch does. Instead, it creates conditions in the gut environment that tend to favor beneficial strains while creating a less hospitable environment for certain disruptive strains. Researchers at the University of California, Davis, studying 64 adults between the ages of 50 and 72 with documented markers of gut dysbiosis over a 16-week randomized controlled trial, found that daily curcumin supplementation produced measurable increases in two bacterial genera that are consistently associated with gut barrier integrity and anti-inflammatory short-chain fatty acid production, specifically lactobacillus and bifidobacterium populations, compared to the placebo group. The methodology used 16S-rRNA gene sequencing, which is currently the gold standard approach for characterizing gut microbial communities at the genus level. The magnitude of the shifts observed were modest, but statistically significant, and critically, were sustained at the 16-week mark. Now think about what that means practically. Your gut is a landscape. The bacteria living in it compete for resources, for attachment sites on the intestinal lining, for the substrates available from your food. When one population grows, it often does so at the relative expense of another. The question is not whether you can introduce beneficial bacteria from the outside, which is the premise of most probiotic supplementation. The question is whether you can shift the internal environment in a way that makes your own native beneficial populations more competitive. That is what the prebiotic modulation mechanism appears to do. The second mechanism involves NF-kappa B pathway modulation and its downstream effects on the gut epithelium. This requires a slightly more technical explanation, but bear with me because the clinical relevance is significant. NF-kappa B is a protein complex that functions as a master regulator of the inflammatory response. Think of it as a control panel that can either turn up or turn down the production of pro-inflammatory signaling molecules called cytokines. In the gut specifically, chronic low-grade NF-kappa B activation is associated with increased intestinal permeability, a state sometimes called leaky gut in lay terminology, where the tight junctions between intestinal epithelial cells become compromised and allow bacterial products to cross into the bloodstream, triggering systemic immune activation. Curcumin has been shown in multiple studies to inhibit NF-kappa B activation in intestinal epithelial cells. What this means for gut flora balance is more indirect but critically important. When the intestinal environment is inflamed, the conditions become less favorable for the colonization of commensal beneficial bacteria and more favorable for inflammatory-associated bacterial populations. By modulating NF-kappa B activity, curcumin may help maintain an intestinal environment that is more hospitable to the beneficial members of the gut community. A meta-analysis published from the Karolinska Institute in Sweden, covering 14 randomized controlled trials with a combined participant pool of 832 adults, found that curcumin intervention was associated with a statistically significant reduction in fecal calprotectin, a validated marker of intestinal inflammation, compared to control groups. The reduction in this marker correlated with measurable improvements in self-reported digestive comfort scores across the included studies. The third mechanism involves bile acid metabolism and its intersection with the gut microbiome. This is one of the more elegant examples of the gut-liver axis at work, and it is one that most people have never heard discussed in the context of spice consumption. The liver produces bile acids, which are then released into the small intestine to aid in fat digestion. What most people do not know is that the gut microbiome plays a central role in the secondary metabolism of these bile acids, and the composition of the microbial community directly influences what kinds of secondary bile acids are produced. Some secondary bile acids are beneficial. They regulate cholesterol metabolism, influence gut motility, and interact with receptors that affect energy balance. Others, when produced in excess, are associated with increased risk of cellular damage to the intestinal lining. Curcumin appears to positively influence bile acid metabolism through at least two pathways. First, by supporting the populations of bacteria that perform healthful bile acid transformations. Second, by directly interacting with bile acid receptors in a way that supports their normal regulatory function. Penn State University researchers studying 112 adults with self-reported digestive irregularity over 12 weeks found that curcumin intervention was associated with measurable improvements in bile acid profile as assessed by fecal metabolomics, with a particular increase in the ratio of secondary bile acids associated with positive metabolic outcomes compared to baseline. The fourth mechanism, and perhaps the one with the most dramatic implications for gut flora support, involves the interaction between curcumin metabolites and the mucus layer of the large intestine. The mucus layer is not passive. It is a dynamic, actively maintained biofilm that serves as both a barrier and a habitat. The beneficial bacteria that colonize the innermost layer of the gut, living right at the boundary between the microbial world and your own tissue, depend on the health and thickness of this mucus layer. When it thins, as it does in many people following years of processed food consumption, antibiotic exposure, and chronic low-grade gut inflammation, the beneficial bacteria lose their habitat, and the dysbiotic shift accelerates. Certain metabolites produced when gut bacteria break down curcumin appear to upregulate the expression of mucin genes, specifically MUC2, which is the primary structural mucin of the large intestinal mucus layer. This is not curcumin acting directly. This is the byproduct of the curcumin microbiome interaction feeding back on the intestinal environment in a way that further supports microbial habitat quality. Think of it as a constructive loop. Curcumin supports the bacteria that break it down. Those bacteria, by breaking it down, produce compounds that strengthen the very habitat those bacteria depend on. Now here's the piece that makes everything above clinically relevant, but that most people get entirely wrong. Curcumin on its own has notoriously poor bioavailability. When you consume it in isolation, the majority is not absorbed through the intestinal wall into systemic circulation. It passes through without being effectively utilized. This is why decades of early curcumin research produced inconsistent results. Researchers were testing a compound without accounting for the delivery problem. The solution is piperine, a compound found in black pepper. Researchers at St. John's Medical College in Bangalore, India, conducted a pharmacokinetic study involving 20 healthy volunteers in a randomized crossover design and found that co-administration of 20 milligrams of piperine with 2 grams of curcumin increased the serum bioavailability of curcumin by 1,944% compared to curcumin administered alone. That number is not a rounding error. It is not a misprint. The combination produces a bioavailability increase of nearly 2,000%. And the explanation is mechanistic. Piperine inhibits an intestinal enzyme called CYP3A4 and a transporter called P-glycoprotein, both of which contribute to curcumin's rapid first-pass elimination. By temporarily inhibiting these processes, piperine allows dramatically more curcumin to be absorbed before it is broken down. This single finding changes the entire calculus of how to approach turmeric as a functional food. It is not about consuming more. It is about consuming it correctly. Here is the exact protocol based on what the research supports. 1 teaspoon of ground turmeric, which provides approximately 200 to 250 milligrams of curcumin, depending on the source and freshness of your spice, combined with 1/4 teaspoon of freshly ground black pepper, which provides approximately 5 to 7 milligrams of piperine. This combination should be consumed with a fat-containing meal. Curcumin is fat-soluble. In the presence of dietary fat, it forms micelles that dramatically improve absorption through the intestinal wall. Without fat in the same meal, even with piperine, you are significantly reducing the amount of curcumin that reaches the gut environment where you need it to act. The timing matters. Morning is optimal for most people. Consuming it with breakfast or a morning meal that contains fat, whether from eggs, avocado, olive oil, nuts, or full-fat yogurt, provides the ideal absorption conditions. Do not consume turmeric in a tea or water without fat present and then eat separately. The fat must be in the same digestive window, meaning within approximately 40 to 60 minutes of the turmeric consumption. Consistency is the non-negotiable. The microbiome shifts described in the research literature were observed over 12 to 16 weeks of daily consumption. You are not rebalancing an ecosystem in 3 days. You are creating a sustained shift in conditions that gradually tilts the competitive balance of your gut community. Missing days matters less than giving up entirely after 2 weeks because you have not noticed dramatic changes. The biology operates on a slower timeline than most people expect. Here are 4 clinical details that significantly amplify results. First, pair your turmeric protocol with a source of prebiotic fiber daily. The combination of polyphenol prebiotic modulation from curcumin and traditional prebiotic fiber from foods like onions, garlic, leeks, asparagus, or green bananas creates a synergistic effect on beneficial bacterial populations. The fiber provides the substrate, the curcumin provides the environmental conditions. They work on different parts of the same problem. Second, minimize processed sugar consumption during the period you are attempting to support gut flora balance. Certain simple sugars feed bacterial populations that are not associated with gut health benefits. You cannot simultaneously create favorable conditions for beneficial bacteria with turmeric while providing competitive advantage to disruptive populations through high-sugar dietary patterns. This is not about elimination. It is about reducing the gradient. Third, if you have taken a course of antibiotics in the last 6 months, your gut flora disruption is likely more significant than the average baseline, and the time required to see measurable shifts will be longer. This does not mean the protocol will not work. It means you should give it a full 20 to 24-week window before assessing results rather than the typical 12 to 16. Fourth, the freshness and quality of your turmeric matters in ways that most people underestimate. Curcumin content in ground turmeric varies substantially depending on how long it has been on the shelf and how it has been stored. Turmeric exposed to heat, air, and light degrades. Buy it in small quantities, store it in an airtight container away from heat and direct light, and replace it every 3 to 4 months. If the spice smells faint or lacks that characteristic earthy intensity, the curcumin content has degraded and you are consuming very little of what makes it functional. The mistakes most people make with this protocol come down to 3 consistent patterns. The first is using turmeric without fat. I cannot overstate this enough. The bioavailability data on fat co-administration is unambiguous. Consuming turmeric in hot water, in a plain tea, or in any format without accompanying dietary fat dramatically reduces the amount of curcumin that can be absorbed and that will ultimately reach the gut environment. The second mistake is skipping the black pepper. Some people dislike the flavor or omit it for simplicity. The bioavailability research makes this a significant error. Without piperine, the curcumin absorption window is so brief and so limited that much of what you consume passes through without meaningful interaction. The third mistake is dose inconsistency. 1 teaspoon of turmeric provides a specific amount of curcumin. Using a light sprinkle in a recipe, split across multiple servings, spread across 3 days of cooking, is categorically different from one dedicated daily teaspoon consumed with the other elements of this protocol. Be precise. Be consistent. The ecosystem you are trying to shift is responding to cumulative, sustained input, not occasional exposure. Let me bring everything together clearly. Your gut flora, the vast community of microorganisms living in your digestive tract, is not fixed. It responds to the environment you create for it through your daily dietary choices. After the age of 50, the natural trajectory of that community tends toward reduced diversity and reduced populations of the beneficial bacteria most associated with gut barrier integrity and anti-inflammatory short-chain fatty acid production. Turmeric, specifically its primary bioactive compound curcumin, has been shown in peer-reviewed research to create conditions in the gut environment that selectively support beneficial bacterial populations through prebiotic modulation, NF-kappa B pathway influence on intestinal inflammation, bile acid metabolism support, and mucin gene upregulation through curcumin metabolite activity. The critical delivery requirement is co-administration with black pepper and dietary fat, without which the curcumin's bioavailability is a fraction of what is needed for these mechanisms to operate at clinically meaningful levels.